Redesign experiences for the future, economic and SDG implications of COVID-19. As Leonardo mentioned last time, he was covering last time the visualization of SDG evolution with Minder. There is a tool that you can use to visualize the evolution of the development goals established by the UN. But in this seminar, we're going to concentrate in some particular challenge that it has on prices that is in the second tab of our web page. That is the economic and stock market implications of COVID-19. There is a company called Quantopian. Let me tell you what is Quantopian about real quick. Are you guys I'm sharing the screen? No. Let me go back and share the screen because I didn't share the screen. Then let me go back real quick. Then the class is research and internship, and this year we're trying to redesign experience for the future, and we're going to try to concentrate in a challenge that is giving some prizes for visualizing the economic and stock market implications. This is the syllabus, but it's still flexible. We're gonna go and check this visualization of information panics, like panics in the news, in a later video. And we'll see the explanation of this graphic that is the introduction to the class on how they visualize how much news and news headlines are given about certain certain events like the Y2K apocalypse, the SARS quarantine in China, the bird flu, the swine flu, and things about video games and other things that cause panic. And those panics cause economic implications sometimes. Then this year, we're trying to concentrate in using data from COVID-19 and probably data from the economic side, especially stock market prices and things that are related to the financial markets, to try to participate in a challenge. Last time, Leonardo did an introduction, just retaking all the things that we have seen last time, like in the Sustainable Development Goals, and the tool Capminder that allows to visualize how these development goals evolve. But actually, this tool is using data from like yearly information, like about population, about poverty, about availability of clean water, availability of health, that are reported by governments usually every year, and then you can see how things evolve through the years. In this tool, you can upload data from the UN and see how they evolve here. In the challenge that we're going to be concentrating, here, this is like the standard visualization where they see how like income and life expectancy are related in different countries. Then they develop this tool that allows to visualize, to see in a graphical way, how like these two indicators of the development level of certain countries are evolving. Then you see how income and life expectancy are evolving, and here inside of the little globes you have the size of the population in each one of the countries. That's the standard tool. That's a tool to do informative visualizations on the evolution of the development goals that we have. In this seminar, we're going to be concentrated in a shorter time visualization that is about trying to connect information that we can get for free from COVID-19, the number of people infected, the number of people dead, geographical information that is available, where they're located, in what countries, in what cities, and trying to connect that information with information from the economy, particularly the stock market. And the goal is try to participate in this challenge from a company that's called Quantopia. Then we're going to see a little video just introducing what is the challenge, but let's read here. This challenge, they call for the community to try to build infographics, visualizations of the economic implications of COVID-19. Then they say COVID-19 had stolen lives, paralyzed economies, and continue to be a threat to life as we know it. Just how damaging the pandemic will be on the global economy is still a question that we like to explore. Then they designed this challenge to encourage you, and we're going to join the community. It's like for free. You can join the Quantopian community to work in this problem, because you are all over the world and you have different backgrounds and interests. We're confident that you will help us look into the issue from various angles and provide insights invisible to others. This challenge, they have challenges. Actually, we're going to see what is Quantopian. It's a company, it's a hedge fund, it's an investment fund. And what they do is try to find people that develop algorithms to manage investments. But because of the COVID-19, they develop a challenge that is different from the challenges that they do. Usually the challenges are develop an algorithm that is like produces profits with these and these restrictions, and manage investment in a stock and futures in the US market. And their model is that if you develop an algorithm that is interested in managing investments, they will give you a part of the revenue, 10% of the revenue that algorithm produce, managing money that they get from investors. Actually, they have like 1.5 or $2 billion, $2 to $3 billion to invest in algorithms. But in this particular challenge, is different from the other ones. What they want to do is that they're asking us to create an infographics to illustrate the impact of COVID-19 in the economy and the stock market. The challenge is broad. It doesn't have like a specific requirements. They just want you to be creative and try to use data science and visualization skills that, as we're gonna try to give you, like the visualization skills that we need to do using a language that is called Python, because in Quantopian everything is done in Python. They give you some data sources, but you are free to use other data sources. We're gonna check in a little bit on other data sources and some visualizations that they have. And they give you a template notebook. Then they give you some data sets that you can use. FactSet geographic revenue exposure is like information from a financial information provider like Bloomberg, but this is called FactSet. And then they provide like what will be the economic exposure of the particular revenue in every sector, depending on the localization that you are in the world. Then let's check real quick what is the information about data set. Then they say this is provided by a company, actually. It cannot be copied or distributed. Inside Quantopian, you can use it freely to do your analysis and your visualization. And then they give you like an information of how companies' revenues, like let's say it will be US companies, but they have companies around the world, are exposed to risk according to the geographic location. Then they say you, inside Quantopian, you can use this free data. They have multiple free data, but they say probably this one is one of the more relevant. Then they say this data is annually reported. The updating frequency is every day. Every day they give you an analysis. They have from the 2004 to the present. And they give you an example here of how to use that data. We will see this later on how you can use this data inside of Quantopian that uses Python. Then we're gonna review today what is Python and what is it about. But you can see here all the regions in the world: country, area code, region code, super region, and then you have data from all those regions. What data? You have particular, like you can slide by regions, but you have the estimated percentage of the income that a company has in a particular location in the world. Let's say Ford, that is a company that produces cars. Then they have a measurement of how Ford company is exposed to risk in Colombia and Suriname, in Mexico, in the United States, and so on. Then we're gonna use data from Quantopian. They have different data. We will explore later on how to use this data in visualizations. Every 2 weeks, they give a prize to the best visualization that they have. Every 2 weeks, they select 10 submissions, and some people check the submissions, and they give you a price of $100 to the top submissions that you guys have. Here we're gonna see the example one, the example submission that they have for this one, just to give you a flavor of the kind of things that you guys are gonna be writing. This is Python pretty much. In Python, you import libraries that are able to do things. We're gonna study those things like pandas that is able to use data like in an Excel file or a Google Sheet file. NumPy for numerical operations, and pretty much these plot operations, these like displaying graphics inside Python. From this on, these libraries are not standard. These libraries are from Quantopian pretty much. And then you can use data. This is not like an easy thing, but here they are just trying to visualize the COVID-19 data, how they are concentrated, the number of cases in different areas, according to like Asia Pacific, Europe, North America, and they say what is the number of cases that you have depending on these dates. It's only displayed until March 24. Then this is like just the number of cases, number of reported cases in every region in the world. And here they take data that is like geographically located, and they do a second visualization analysis like this one. Then here is the number of cases, and here is some visualization that they try to analyze how companies located in certain areas are exposed to risk in those particular areas. This is a simple example just to try to use those data, but we will get there later on how to try to do a more interesting visualization in Quantopian. Then let me close this one. And where is the video? Let me go back real quick here. Then we're gonna have a short video. I don't think how short it is, where the vice president of research in Quantopian tries to show.
VP of Data Science at Quantopian, and today I want to introduce our newest challenge on economic implications of COVID-19. This challenge is a little bit different than the other ones we have done before, where previous challenges we asked you to develop a quant trading factor that would be predictive in the market. But here we're asking you to provide an analysis and visualization that illuminates what the ramifications of COVID-19 are on the world economy or the US economy. So here I have the website open for the challenge. You can see if you go to the Internship forums, there will be a post in there. And the idea is that in this thread, people will post their
Professor, we don't see the video.
that combine.
You guys are not seeing the video?
No, we're just hearing the sound, but not seeing the video.
Market data and potential.
I don't know if I didn't share the whole thing. Let me go back real quick. Are you guys seeing my screen or not?
Yes, we're seeing your screen.
And you see the video before playing here?
Oh, that's the video. Okay. I thought it was a document.
No, no, no. It's the guy like mentioning like the same document that we were seeing before. That is this. But
Oh,
he's
okay.
explaining what is the challenge about.
Okay.
It's like pretty much like a double explanation of the things that we are.
Hi everyone, I'm Thomas Rieke, the VP of Data Science at Internship, and today I'd like to introduce our newest challenge on economic implications of COVID-19. This challenge is a little bit different than the other ones we have done before, where previous challenges we asked you to develop a quant trading factor that would be predictive in the market. But here we're asking you to provide an analysis and visualization that illuminates what the ramifications of COVID-19 are on the world economy or the US economy. So here I have the website open for the challenge. You can see if you go to the Internship forums, there will be a post in there. And the idea is that in this thread, people will post their Jupyter notebooks that combine market data and potentially also COVID-19 data. In order to do this analysis, we added the COVID-19 cases, the number of confirmed cases and the number of deaths over time for each different country onto the platform, and you can access it there. So what I want to do in this video is briefly illustrate how to create such an analysis with an example case study that I created. So here's the notebook, which is also attached on this post. And ideally, this is the outcome of this. So we want a single plot that is hopefully illustrative and shows some interesting results of the relationship between this pandemic and the real economy. So here now I opened an example of a notebook showing how to analyze this type of data set. And I hope that
we will go back into the explanation of this notebook because this will be the template that we'll be trying to use to develop our own infographics. And later on today, we're gonna open our account in Quantopian, then just today to explore the Python infographics. Then this is in the second tab, visualizing. The first one is the syllabus, like this syllabus here. The second one is the presentation from Leonardo last time. And today we're first reviewing what is the goal of our class is to try to develop a good visualization of relationship between economy and COVID-19 cases and try to upload this into this challenge and see if somebody from the class can get one of the prizes there. Then you have here the video where he explains at the beginning what is the goal of the Quantopian challenge. And later on, he explains, from the point that I stopped the video, he explains how this example of visualization was built inside Quantopian. Like 90% of the things here are Python, and there are some special libraries that are from Quantopian itself. There are libraries to be able to use data that Quantopian buys from providers, and you can use to do the analysis and to do the algorithms actually that they develop. Then before going further, we're going to check here in Wikipedia Quantopian just to tell you what is Quantopian. Then Quantopian is a financial company. It's a crowdsourced hedge fund. They have two sides of the business. It was founded in 2011. It's a company located in Boston. The founder is John Fawcett. And the business model has a two-side business model. In the first side, they provide to people around the world for free the possibility of writing trading algorithms in a simple language called Python that we're going to see later on. And if the algorithms to manage investments in the US market. Then they say the first side consists in allow algorithm development members to develop and test for free algorithms that have factors that guide the investment decisions. And in the other side, they have investors. Then they give you for free all the possibilities of using Python, that is a widely used language, plus some special libraries that allow to use information that is financial information that is expensive, but for inside the platform is free for you to be used to develop those factors that guide algorithms that decide where to invest money. And in the second side, that's the first side, they give you for free Python access. We're going to see how it works. Two kinds of Python access. One to test algorithms that are managing investment, and the other side, that is the one that we're going to be using in our challenge, is called a research environment that is like an interactive Python notebook where you can do small pieces of like programming and see the results and actually see the like the results of the instructions of Pythons that you write in a particular like little, they call cells, and you can see piece by piece all the analysis and the graphics that you are like developing inside. Then they give you that. And the second side is they get investors to put money on the algorithms if the algorithms are like interesting. Then they say they want algorithms that manage like millions of dollars, no like small amounts, like with larger resources, more than 1 million, 10 million, things like that. Then that's the company. And the company, because of the COVID-19, open a challenge that is not exactly in the line of business, but it's also sort of, because they say, we like to see good analysis of how a pandemic like COVID-19 impacts the economy, and probably it could give insights into potential strategies for managing like investments. Then here is like, we're gonna go back at some point into the explanation of the template visualization that they provide and the explanation of the data sets that you have inside Quantopian. But they also say in this one that not only you can use the data that they have there, but also you are free to use any other data sources that you can find. And there are many public data sources about COVID-19, but actually there is not too much information. Usually it's like number of cases, number of tests, number of dead people, number of people recovered, and they are like geographically located. Actually, one of the sources that is the most widely used, where they have data, but also they have a visualization, is the Johns Hopkins University Coronavirus Resource Center, where actually they have a visualization of how many people are like infected around the world. And actually what they do is also what they call a curation of data. They collect data from governments, from hospitals directly, from healthcare providers, because some of the data for central governments are not like very reliable. Then they have here the map of number of cases around the world. This is confirmed cases, this is active cases, this is the incidence rate, the case fatality, the testing rates, and actually you can see particular like countries here, let's say Russia, and then you have the total number of deaths. In other places you have a more detailed information like United Kingdom, they have the total number of cases, and they have also a particular case where they have the US map showing this data, and it's available for like everybody. Then in the US, they have a detailed data, state by state, and actually county by county on the number of like dead people, the number of infected people, and stuff like that. They also have the critical trends. Then that's one of the sources, and also you can access this data that they collect in a way that we will see later. Then that's one of the sources of data, the COVID-19 data, and in the other side, you have financial data. And the idea is to try to do a visualization that connects or illustrates impacts from the pandemic on the economy. Actually, they have the data inside the Quantopian platform, then you don't have to go and load it. They have the data updated day by day in the data directory in the research area in a particular file. Then inside Quantopian, you will already have detailed country by country, day by day, what has been the number of new cases, new deaths, total cases, total deaths, and this information. But also you can use other data. What other data? There are like data is available. Here we're gonna see, this is Kaggle. It's like another place where they do competitions on machine learning and visualization. And they have here visualizations and data that is available. In particular, they have notebooks here. Let's see, inside story of each country. You will see visualizations that are done in the same language that we have here, Python. You guys gonna see this quite frequently, like imports on libraries. This is another library that is not standard, but it's for plotting. And then you can do analysis of this data, like in different ways. Let me see if it's, why it's not, it takes a little bit probably to upload the data. Then they have a competition on global forecasting, like to do good forecasting about these things. Let me see. It's running still. This is loading this package of like plotting. I don't see the figure here yet. But these are examples of visualizations, and here you will see they will describe how they collect this data. Like they have Afghanistan, they have latitude, longitude, date, confirmed cases, things like this. And this data is uploaded from some areas in Kaggle where they have data in comma separated files, similar to the ones that, like actually one of the type of Excel files or Google Sheet files, would you have values separated by commas? We will see that later. I don't know why this one didn't upload like correctly, but let's see another one. Let's see this one. Then they have here like the files, pretty much the same information that we have there. Is the number of cases located by latitude and longitude and country. And just with some instructions, you can do a plot like this. Worldwide number of cases confirmed time at this point. Worldwide confirmed cases logarithm scale. Then they do logarithm in the number of cases. Then this is the same representation of this, but this is a logarithm scale that is connected to do like from here to here you have 1,000, from here to here you have 10,000, from here to here you have 100,000. Then it's something that allows to see larger values in a scale where you have powers here, like 10 to the power of 3, 10 to the power of 4, 10 to the power of 5, let's say. Then you can see larger numbers in a smaller scale, but then you have to make sure that what happened here is that the number of cases is multiplied by 10. You have the same distance here is 10 times the one before, and the distance here is 10 times before. Then this is not a number of cases, but it's a scale that is logarithmic to be able to plot those things. Then they do visualizations like the number of cases in China, number of cases in Italy, things like that. And they also can, using some libraries, they even can plot maps with this. Where is the place where you have more confirmed cases at to some point? In these visualizations that you have in COVID-19, in the Kaggle, they actually are concentrated pretty much on data from COVID, only COVID, number of dead people, where are they located, how many people you have in some places. But there is no connection with like unemployment, certain companies losing value in their stocks, and things like that. Then what we're going to try to do is use information like this one and connect with economic information that is inside Quantopian and some other economic information that is available outside. Then in this page, you will find multiple visualizations of COVID-19 here where they say notebooks. It's possible that you will find visualizations that are connecting effect of temperature on humidity in visualization, COVID-19. Then they have temperature by country, and they are trying to connect temperatures with the number of cases. Then they say here, temperature connected with confirmed cases, country by country. And this one, it looks like it's only Russia, but I don't know why you concentrate only in Russia, but now we're seeing like other ones. Ah, no, this is China, sorry. Then from this day to this day, they check temperatures in the country and the number of cases to see if you can see something that is interesting. Then here, they confirm logarithm number of cases versus temperature. Let's see. In centigrade degrees. Then these kind of visualizations, if you check here, these visualizations are done just with like very simple instructions in Python, using some libraries that allow to do like dynamic visualizations of some sort. Then you guys here have these things to try to get inspired, and sometimes just like copy the idea and use some particular data. We will have to check if many of these libraries are available, of the visualization libraries are available inside Quantopian, because we will only use the things that are available inside Quantopian. Then you have the challenge here, and you have other references here. I was mentioning before starting that in the syllabus, we were mentioning this visualization that is like famous because it tries to illustrate how news are connected to the panics in society at certain points. Then we're gonna just check the video here, a video that I think we saw with you guys at some point. that is this TED video. Can I move this? Ah, yes, I can move it down. This, yes. This was this one. This is this one. No. Here. Then I'm not gonna go into the whole video, but just go to minute 247. Say here.
It's kind of useful. So I want to show you another landscape now. I need to imagine what a landscape of the world's fears might look like. Let's take a look. This is mountains out of molehills, a timeline of global landscape now. I need to imagine what a landscape of the world's fears might look like. Let's take a look. This is mountains out of molehills, a timeline of global media panic. So I'll label this for you in a second. But the height here, I want to point out, is the intensity of certain fears as reported in the media. Let me point them out. So this, swine flu, pink. Bird flu. SARS, brownish here. Remember that one? The millennium bug. Terrible disaster. These little green peaks are asteroid collisions. And in summer here, killer wasps. So these are what our fears look like over time in the media. But what I love, and I'm a journalist, and what I love is finding hidden patterns. I love being a data detective. And there's a very interesting and odd pattern hidden in this data that you can only see when you visualize it. Let me highlight it for you. See this line? This is a landscape for violent video games. As you can see, there's a kind of odd, regular pattern in the data, twin peaks every year. If we look closer, we see those peaks occur at the same month every year. Why? Well, November, Christmas video games come out, and there may well be an upsurge and concern about their content. But April isn't a particularly massive month for video games. Why April? Well, in April 1999 was the Columbine shooting. And since then, that fear has been remembered by the media and echoes through the group mind gradually through the year. You have retrospectives, anniversaries, court cases, even copycat shootings, all pushing that fear into the agenda. And there's another pattern here as well. Can you spot it? See that gap there? There's a gap. And it affects all the other stories. Why is there a gap there? You see where it starts? September 2001, when we had something very real to be scared about. So I've been working as a data journalist for about a year, and I keep hearing a phrase all the time, which is this: data is the new oil. And data is a kind of ubiquitous resource that we can shape to provide new innovations and new insights. And it's all around us and it can be mined very easily. It's not a particularly great metaphor in these times, especially live around the Gulf of Mexico. But I would perhaps adapt this metaphor slightly, and I would say that data is the new soil. Because for me, it feels like a fertile, creative medium. Over the years, online, we've laid down a huge amount of information and data, and we irrigate it with networks of connectivity, and it's been worked and tilled by unpaid workers and governments. And all right, I'm kind of milking the metaphor a little bit, but it's a really fertile medium. And it feels like visualizations, infographics, data visualizations, they feel like flowers blooming from this medium. But if you look at it directly, it's just a lot of numbers and disconnected facts. But if you start working with it and playing with it in a certain way, interesting things can appear and different patterns can be revealed. Let me show you this. Can you guess what this data set is? What rises twice a year, once in Easter, and then 2 weeks before Christmas, has a mini peak every Monday, and then flattens out over the summer? I'll take answers. Chocolate. You might want to get some chocolate in. Any other guesses? Shopping. Yeah, retail therapy might help. Sick leave, yeah, you'll definitely want to take some time off. Shall we see? So, the information guru Lee Byron and myself, we scraped 10,000 status Facebook updates for the phrase
So the idea is to get inspiration to try to do a nice infographic that connects economy and the information available from coronavirus in any creative way that you guys can think of. Then we have the data. Inside Quantopian, we have the data from COVID-19. And inside Quantopian, we have data from economic, actually financial data from multiple sources. We will explore how to use it and how to plot it. And you guys will try to see what kind of analysis or what kind of like connection between the data and what kind of visualizations you can do. And if you find something interesting in the notebook, actually, in the notebooks, you can plot things, analyze things, and also describe in test your findings to show that you did a visualization that is revealing something interesting between these two things. Actually, the one that he does is not very, if you go into his notebook, he does this and he gives like a very simple explanation here. Actually, what he's saying here is that there is no seem to be an obvious influence of confirmed COVID-19 cases onto returns of companies exposed to the region when the confirmed case shows over the chosen threshold. He says over this threshold, he's plotting the risk, trying to see if there is a connection between the number of cases in certain region and the size of the risk exposure that they measure by a data provider. And then it's like, there is no something that I can see here that you connect like easily to try to give an explanation. Okay, then the second part of the class today, we're gonna try to give an introduction. Then so far we have covered what? Last time visualizing SDG goals. Most of the SDG goals are economic goals, poverty, salaries, employment, and those things are heavily connected with financial things, because when companies go down in their values, they mean they get less money from investors, then they can hire less people or develop new and more innovative services. Then when we go into financial variables, then we're getting things that are connecting to SDGs, like employment, value of the companies, GDP, things like that. But we're doing these things in a lower time scale because our analysis is gonna be probably from the end of December, when they have the first data reported, up to the day that we run the visualization is gonna be 2 or 3 months. While in Gapminder, you explore things, how the development goals change through years, through decades, like from 1960 to 2015. Imagine that our analyses are gonna be just concentrated in the time that we have the pandemic, that is this month, and the data that they provide us on how the economic variables and financial variables are being changing in these times. Then the idea is to try to illustrate things that we can find interesting like this in a visualization that we can submit to the Quantopian challenge. Questions up to here? Are you guys hearing me okay? Before we go into the Python introductory thing, and after these 2 classes with Leonardo, the past one that was like a review of Gapminder, and the one today that is gonna be an introduction to the Python ecosystem, and probably today we will start with some little explanation in Quantopia. We will start doing practical exercises because the idea is that you guys build one visualization, each one. We're gonna work probably in groups of 2 or 3. We have like 6 people in the class. How many people do we have in the class, Julian?
8.
8. Then probably 2 groups of 4 or 3 groups, 2 of 3 and 1 of 2, whatever you guys decide. but at least we will have 2 visualizations to try to submit there and see if any one of you guys can win the $100 with like anything that we can do. It's a long shot because you have people with more experience in that community of Quantopian, like in programming and stuff, but the creativity sometimes trumps the experience in programming, and some people do really nice visualizations of things because they put their creativity in exploring things that maybe some other people don't explore. And you see, they are trying to see these things around the world. Then if we can get things that are connected to the Caribbean region or Latin America, it could be interesting even for them, like how the economy and the companies and the exposure of companies around the world are being affected due to the impact of the pandemic in our region. Then if you guys, the thing is, we have probably very limited information besides that risk by regions of the US companies to try to get information on the economies, like how the economies of our region are evolving in these years. Like we don't publish publicly that much. Then probably we will have to be connected to the exposure of the US companies to the how that information that Thomas used in his visualization, but we can illustrate it in a more like more visually communicating way than the one that he did, the simple one that he did in his analysis. Okay, then since there is no questions, I'm going to tell you what is Python. Python is a programming language, and we're going to see in Wikipedia that actually it was a programming language that was developed by a guy from the Netherlands. If I'm not wrong, Guido van Rossum. Let me just check quickly. Yeah, it's from the Netherlands. There are thousands of programming languages. There are thousands of languages to program a computer to develop a task, like C, Java, Basic, C++. If you check programming languages, you find like thousands, and then you're like, but why if like it should be like just 1 or 2 languages to tell a computer how to do things? The thing is, like, languages are developed by people with particular interest. Then if you guys check programming languages in Quantopian, sorry, in Wikipedia, you will find there is a list of programming languages, sorry, here. Then you find like all these languages that are like Algol, something like that, all like by B, this number of languages, C, C++, C#, and so on. And you're like, why so many programming languages? Because some programming languages, I focus on certain things. If you go and check one called COBOL that is very old, was Common Business Oriented Language. That's the name. It was a language that was developed in the 1960 something, 1960, to do pretty much payrolls, like all the accounting things. Then it was a language oriented to business. Then you have languages like BASIC, that it must be here, that is actually, it was very similar to Python, but very old. It was beginner's all-purpose symbolic instruction code, a very simple language that you can use, and actually it was similar to Python. We're gonna see why, because it's an interpreted language. At the beginning, like in the 1964, they say, this programming is sort of like strange. Let's develop something that is easy for people to understand and to write, and they can tell a computer, do this with this information that we're providing with this data, and do this procedure and finish this. Actually, BASIC was a very popular language that it was developed in a university called Dartmouth College, and it became actually famous because it was easy to use in the Atari, a very simple and cheap computer that was one of the cheapest computers that was available, and then it has a basic interpreter that you can tell the computer do this, and then it was easy to do. But then it became like out of like people kind of lost interest on the language for some time and then kind of disappeared. Then this guy, Guido Rosum, he wanted to revive a language that was very simple, and the idea was to be used to teach kids how to tell a computer to follow a procedure to solve a problem. Then the concentration of Python was in something called readability. It's like the idea is when some people write something in Python, as soon as you read the instructions, you can understand what is the computer being told to do. There is not much like syntaxes, like complicated syntaxes. It's something very similar to very simple English. Basic was pretty much the same idea. It was something like in very simple English. The only thing it was like, because it was all it needed, like numbering the lines, line 1, line 2, line 3, and it has a syntax. Python kind of revived this thing in the 1990s. And the idea was to make things super simple for programmers. Then like programmers and people that write, like actually kids that are trying to write programming, no like Scratch with graphical interfaces, but instructions telling the computer, do this, then do this, then do this. Is a imperative language where you tell the computer, do this, and you're doing it in a syntactic way, like similar to English. And it became very popular. It was a successor of some other language called ABC language. And it became very popular. And even though it was developed by this guy from the Netherlands to make something readable and not to make programs near efficient, extremely fast, it was not concentrated on details. It was not to develop initially like big software systems. It was just to teach kids on the rudiments of how to tell a computer to follow a simple procedure. But then it became widely used by some people in sciences, like physics. They used to program in some specialized program that was in a specialized language used to call Fortran. Formula Translator was one of the first languages, but it was like connected to mathematics and heavily complicated in the syntaxes. It has a number of spaces, it uses some particular representations, and it was sort of like difficult to program. Then some people from sciences, it was like Python is very simple to use to understand how to do a procedure, but it has a problem. It was developed to be easy to use, and it's not very fast, and it doesn't have like special structures to do mathematical formulas and to work with data. Then some people develop these things that is called interactive Python. That is something that we're going to use. An environment, because Python is interpreted, it's not compiled. You can give an instruction and you can see the result immediately. The result of an instruction is interpreted by the computer immediately. You don't write a whole program and then compile the program and run the program with some input, and then you find a mistake. In Python, you can do one instruction and see the result, do the following instruction and see the result, and so on. Then they develop an environment in which you can see interactively the results of your Python instructions very quickly, and also combine that with text and graphics. Those are the notebooks that we're mentioning there. And they developed something called Jupyter that is like the same notion of interactive Python books, but for Julia, Python, and R. There are 3 languages that are used in data science and visualization and machine learning and things like that. Then actually we're going to be using sort of Python notebooks, but actually we're going to be using only Python. That is more like interactive Python, not Jupyter. And because people started using these things for mathematical operations, then developed something called Cython. C was a language that was extremely fast. Then they built a library that allowed to introduce pieces of like language C inside the Python when you wanted to do something like fast. But that was superseded by a library inside Python that was able to do numerical operations called NumPy. Then it's a language that was developed to teach kids, but suddenly it was extended with libraries to be able to use like mathematical computation. Very similar to Fortran. C was not developed to do mathematical computation, which was heavily used because it was very close to assembler, the machine language that is very fast to execute. And on top of that, they developed, actually we're gonna see in a minute, pandas. That was a library developed by economists. It's called panel data. It's Excel files where you have, initially it was panel data, the one that the economists collect, that they collect what was the GDP this year, and it's like 1985, 3%. 1987, it was time series, like data in which you have a data, like data stamp, like data and type stamp, like date and time, collection of data, and a variable that is being collected in those particular dates. It was usually what the economists use is economical data, and they call those kind of data panel data. A panel data where you have the timestamp and the variables collected. It could be just one variable or multiple variables. Then we will see in a minute that some guys develop this thing for like economists or econometricians, and some guys develop like a library to do plottings, like displays, graphics with data. Then we're gonna be using Python, IPython, sometimes NumPy because we have to do certain operations without data, panel data, and matplotlib here. And sometimes we have more advanced visualization like libraries on top. Here, we are not gonna run into this, but they have a library of machine learning, and now this language is like the most popular language in the world. Let me just check real quick here. Just for you guys to see how popular is Python. If you guys check last year, what were the programming languages that were more widely used in a study that is done by this organization that is the Institute of Electronic and Electric Engineers? Then they say Python was the most widely used language in the United States by software engineers and programmers. It was, they say here, they did a survey of around, I don't know, 10,000 people. The second one is Java, the third one is C, the fourth one is C++, the fifth one is R, the sixth one is JavaScript. Then this is the most popular language now, and it was not developed neither for mathematical computation, nor for machine learning, data science, or software development, but now it's being used in those areas because they extend the language with libraries. And once people learn Python, they prefer to extend the language with capabilities to do other things than to go and program in a particular language that is specialized in that particular area. Then that's the reason that Python is becoming very popular. The language core is very simple to learn. And if you need to go into certain area, then there is libraries that allow you to do those things. And then you only have to learn on top of your Python certain libraries. That's what we call the Python ecosystem. It's a Python in the core that we're gonna see in a little bit with you guys, a little introduction to Python. And there is these things like libraries. This one is close to the scientific Python ecosystem, but also you have on top of Python other libraries that allow you to do applications in fonts or applications in servers or process big amounts of data in something called PySpark. Then there are libraries on top of Python that allow to tune the language and expand the capability of the language to tackle different areas. Then we were reviewing the history of Python, then started in 1991. The emphasis was in code reliability. It used indentations like humans use to make things like in a different hierarchy, like this instruction is from this hierarchy, this instruction is from the other hierarchy, while other languages use brackets and things like that, and it becomes sort of complicated. This one is like, you write like similar to English. If you want a text that is in one hierarchy, you put it with one indentation. If you want a text with lower hierarchy, you do it with other hierarchy, and then it uses significantly wide space. In Python, we're gonna see in a little bit something more technical. They say it's dynamically typed. In other languages, you have to declare variables at the beginning and say this and define the type of the variable. This is a string, this is a letter, this is a number, and then you cannot change the type of the variable. In Python, they say, no, that's too complicated for programmers. This thing is like when you declare a variable here, we're gonna see what's a variable. It's something that you put something in memory with a label. The label, the name of the variable, gets the type of the particular type of data that is contained in us at that particular time. Then it's dynamically typed. The types of the things are controlled by the execution. Once you assign something to something, it becomes that way. Then you can have a variable that at some point is called X, it has a number, and then following that you assign to that particular variable a string, and the language doesn't have a problem. While in other languages, you define the times before, and then you have to respect the time. If this is a number, you cannot assign anything else than a number along the instructions that you are constructing. That was to make things easy, because the type declaration makes things more complicated for like people that are like starting to program. And another thing that was like very technical is this thing called garbage collector. Then in other languages, you are responsible, you request memory from the computer to store data, and you have to return that memory when you finish using that memory that you use to store data. And sometimes that thing has like technical details and leads to errors. Then in Python, you don't have to worry about that. If Python realizes you are not using anymore, like some object is not being referenced by anybody, anywhere else in the code or something, it goes and destroys the object and returns the memory to the operating system, to the computer, to be used if you need it ahead. Then there is something called garbage collecting, like data that you store in some particular part of the computer under some name or some label or in an object inside the computer that you create. If you don't need it in the future, you don't have to worry to destroy the object and to return the memory. There is part of Python that is checking that something is not being used anymore, and it collects that, returns the memory to the computer, and you don't have to destroy objects that you're not going to use or data structures that you're not going to use in the future. Then that's Python. There is the story of Python. Actually, we're going to use Python 3. The initial Python 1 was something, then they developed something Python 2, and now they have Python 3. We're going to use Python 3. That is the last version, but they didn't change nothing in the core, but they changed some syntactical things and some characteristics of the language through these 30 years to improve the language without destroying the compatibility with all the things that we have available so far. Actually, from the Python 2, there were like different versions, Python 2.1, 2.2, 2.3, 2.7, and this Python 2.7, 18 was the last 2.7 release, and then they moved to the Python 3.5. Then this is the creator of the language, and actually it was a multi-paradigm program. We're gonna see not too much details, but we're gonna go directly into Quantopian today to see like little bits of Python to start to explore how you do programming in Python. Then you guys have to go into Quantopian. The webpage of Quantopian is this one, www.quantopian.com. Let me enlarge this one. And when you go to Quantopian, you will get a page in which you can register for free. Then this is the web page of Quantopian, and here in sign up, it takes a little bit because they check. You have to write your name, your last name, your email, fix one particular password that is gonna be your access password, accept the terms. If you want the news from Quantopian, when they have news or things like challenges or something, you leave this box mark. If not, you leave it without the mark. Then you guys create your account in Quantopian and let me know when everybody had the account created in Quantopian. Then today we're gonna cover Python and interactive Python here, actually up to Jupyter. Later on with Leonardo, we will cover NumPy, Pandas, and some of the visualization libraries that we can use here. But today we're gonna give a short introduction to Python for you guys to start exploring the Quantopian platform and the Python inside there. Please let me know, open the mics and let me know when you guys are inside the Quantopian platform. What?
No, I'm asking if they are already there. Has everybody
okay.
managed to log in?
Yep,
Idrina,
okay.
hello.
Yes.
Okay. Then I'm gonna use my account that I have already in Quantopian with my email. Then you guys will see something like this. This is the Quantopian environment. Here they have like Quantopian forum where they publish news and things like that. And they have here the newest post, the latest ones. But here we're gonna move into something called Learn, and they have lectures. Then in Learn, they have an introduction, what they call research, but it's actually interactive Python. And we're gonna see what is that. Then you guys go by Learned, Lectures, and open this introduction to research. You will see something that has like test and some boxes that we call cells, in which you have Python instructions. In this one, we're gonna see simple Python instructions today. Then if you do clone notebook, it makes a copy of that notebook in your notebook directories. They call it here research, notebook directories. And you guys can execute instructions. Then we're gonna have some of you guys, after you clone the notebook, execute here and do little experiments with this environment in which you can order the computer, do this operation, and then the computer will do it. Then let me know when you are here in the clone introduction research 6. It's because I have other 5.1. I'm gonna change the name here. I'm gonna put Suriname introduction to research because it's this one. Then I change the name of my plot. I can save this notebook with this particular name. Then you guys are already here because we want to start, and then I'm going to ask some of you guys to show me results of things. Then in notebooks, you have two types of cells. Each one of these little blocks is a little cell, like a little node inside of the notebook. And you have two types of cells. Actually more, but here we're gonna check only two. One that is called Markdown, that is text, descriptions that you describe. And the other one that is code, that are little pieces of Python instructions. Then, if you guys go and click in this one, actually we're gonna see in a minute like a Markdown thing, but in Markdown you can write text, and Markdown has like a super simple language to define what is a title, subtitle, and things like that. Then if you put something like this, and then you plot this, it changes the title to a subtitle. If I put 2, if I put 3, it's a level 3 subtitle, 3 pound signs. The number of pound signs, the pound signs is, if it's pound 1, it's like title. Then it puts like the, and the rest here in this particular cell is just a text, a description of something. Then introduction to research environment. The research environment is an interactive Python notebooks which allow you to perform a great deal of data analysis and statistic validation and also plotting, we will see later. And they're gonna show in this lesson how to use this. Then the first thing is this. Actually, let me check real quick the Markdown.
Okay. Professor,
Yes.
I think I missed something.
Okay. Let's go back. Can you show me the screen to see in what point are you?
Wait. We go to learn. Let's see. Wait.
Yes, learned. Lectures.
Lectures.
Yes. And in lectures, you open the first one. All of these are lectures, but we're gonna cover only these 5 that are how to use interactive Python.
Yeah.
The Python introduction, how to use numerical data, how to use panel data, and how to plot. But today, probably we're gonna cover just a little bit of this one because we're going slow. But then when you open introduction to research, you can see the lecture, but that one cannot be changed.
Okay.
To be able to change, you have to clone the lecture.
Okay.
To make a copy. And then you have a copy in which you can work. And then here, if you double click in any of these cells,
Okay, now I see. Okay.
you can edit the cell. And if you wanna render, they call it render because it produces the final version. Then you go to this thing, like say here, and I'm gonna cancel this one. Leave. I'm gonna show you like what happened when I go out, just to make sure, because I clone my lecture and I call it Suriname. I have one and I have the last one that I cloned. Then I can delete that one. But to be able to delete, because he's running that notebook, I have to stop the notebook, shut down the notebook, and I delete the notebook. If I wanna delete some particular notebook, I delete the notebook. He asked me, do you wanna delete that one? And let me go back to my Suriname research introduction. Then in this one, I was telling you, if you guys are here, if you click a cell, it could be a text cell like this one, that it has titles, subtitles, things like that, text. And we're going to check this called Markdown cheat sheet. I'm gonna put that in the links there. There is, in this one, is like, this is the syntax of the text cells that you can write inside the notebook. If you want a title level 1, then you put pounds and the title. If you want a title, subtitle, 2 pounds. And then if you want a subtitle and smaller title, then you have 3 pounds and then the title. Then that was the thing that we were doing here. This is a title. If I want to make it a subtitle, then I put it like this. And then I say, do it like this. And then you have a smaller like font for that one. If I do 3 pounds and I do this, then I get even a smaller cell. But let's go back to the first one. It was this one. Then this is a text cell called Markdown because it has text, but it also has all of these things. You can put text that is in bold. Then if you want to make like a little comment and say, but I want this to be bold, then it's like IPython notebooks. And I want that comment to be like this. Then here it didn't work. Yes, it worked. You have this in a bold thing. Then you have ways to use like italic letters in your test. Like this is a block quote, like order list. Then you put 1, 2, 3, 4, an order list like this. And if you want to leave a little piece of code, like to be shown like code, then let's say here, I'm going to say the first instruction, and this is an instruction I do. Let me copy from here because it has to be this particular one. X 2 plus 2. Then it's gonna be shown as code in the, it's like in a little box saying, this is an instruction of Python, but it's not executable. It's just a comment like describing something. Then it's a very little text description code for headings this, for types of letters this, for lists this, for code this. If I want an horizontal line, I put 3 little lines here. Let's say, if I want to say like, after this, I want a line, then I do 3 lines, and then I have the markdown comment there, like with the line. Then it's a little description text. In this text cells, I can use all of these. There is also, actually, this is pretty much what you have. Like, you can insert graphics too, but we're not gonna use that one here so far. Then here they have 2 text cells, what they say, actually is what they are describing. Inside the notebooks, you can have either text cells or code cells. The text cells have text with that description that is marked down, if you want title, subtitle, lists, and then you have command cells. Actually, you can introduce cells like this. If you are in this cell and you want to create a new cell, then you create a cell. Here you select this like markdown cell, okay? And I want to subtitle, hello, everybody in Suriname. And then I run, and then I have this cell with this text, this other cell with this text, and I can add cells just selecting a cell and saying here, add a cell. Then this is like text, just to describe your things, use title, subtitle, list, and things like that. If you want to create an instruction in Python, then you open a cell and you leave that cell as code. Code is like instructions in Python. And here there is the first example. You can tell Python, use Python as a calculator. Say like 5 plus 3 and ask for the result. How you get the result of the execution? You write anything that you want to be calculated here, and then you use this run, and it executes and give you a result immediately after the instruction that you order, like 5 plus 3. Let's say I can do another calculation, 5 plus 3 multiplied by 4. The multiplication here in Python is with star, not with this one. Here, if I'm not careful, but I want to make it explicit, I say first do this multiplication and then add this. Then I have 12 plus 5, 17. Then I'm going to get that result. Then in this kind of environment, I can give an instruction and just have the result immediately printed. What kind of instructions? Initially, you can do anything with arithmetics with integer numbers like these ones, or floating point numbers. You can say like 4.3, and then you don't need to tell anybody like this is an integer. He will realize, oh, okay, this guy is a floating point number, this was an integer, this was an integer, but the result is a floating point number. It's like, okay, the result is 17.3 because it's 5.3 plus 3 multiplied by 4. Then he does all the changes. In other languages, you have to make everything float like this, 3.0, 4.0, or you have to do some rules because he cannot operate between different types. In Python, he figures out how to solve problems if something is not from the same type. Even, let me see if this works. Let's say something like this. Probably it's gonna give us like, it's like, this is a string, this is a number. I cannot add this thing because one is a float number, floating point number, and the other one is a string. But I'm gonna do a little trick here. I can make 5.3 a string, and then he knows that plus is a concatenation. Then it's like, make this value into a string, and plus becomes like, join these two strings. Then you can do all those kind of things, we'll see later. Execution of commands immediately. Then you write a command, and you see the result just immediately running this. If you want to store your notebook with the changes and go out, here I have multiple notebooks, but the last one is this one. And I want to come back, I see the things with the results of the last execution. This one is empty, means I didn't execute this one. Then everybody try to do an arithmetic operation with either floating point numbers or integer numbers or mix of float point numbers and integer numbers in this cell, in the first cell. And please show me the results. Change this instruction for like an addition plus a multiplication plus something, and show me the result. Just to make sure we have everybody in the same page. Then just share you guys can share the screen. Yes, I'm sure. Let me see. I stopped sharing, and let's see a couple of examples. Somebody that shows me the change that you guys did in the first notebook, changing this instruction that we have, 2 plus 2, for some more instruction and seeing the result.
Only the 2 plus 2 is a change.
Say that again because I didn't hear you clearly.
Only the 2 plus 2 they should change.
Yeah, just this for one, and then we will start changing other cells and explaining what is the following one. Then in Python, you can use Python as a calculator just to do arithmetical operations in one cell and see the result.
It
just
doesn't
that
matter
first one.
which.
No, it doesn't matter. Change it for some other arithmetical operation that combines multiplication plus addition. Multiplication as star and addition. It could be just integer numbers. It could be floating point numbers, 5 point something, 3 point something. just leave Python to do that, and just change that one and go and do the run and see the result that you are obtaining in that particular one. Then any volunteer to show me the change? They can take over the screen and share the screen, no? Julian.
I think so because I think so because I have the share screen. Can you guys share also? If iedereen ook die share screen optie? Hebben jullie ook die share screen optie? Hallo?
Welke optie?
Dus kunnen jullie ook share screen doen als je iets hebt, zodat we kunnen zien?
Laat me even kijken, want je vecht met zoveel dingen. Even.
Ryan, Fania, Steven, share.
Hi Julian, die share screen optie zie ik, ja.
Ik zie het ook.
Oké, wie wil delen dan? Heeft iemand het kunnen veranderen? Dat vraagt hij.
We zijn nu nog even, ik ben tenminste nog even bezig.
Oké, wie staat zover?
Ik heb wel share screen, maar ik ben nog niet zo ver. Ik ben een beetje traag dit keer.
Alleen die 2.2, 2+2 moeten jullie veranderen. Niet veel. Mag anything veranderd worden. Can change into anything. Just to 2+2.
Moet nog even inloggen, ik was even niet bij.
Ja, ik log ook even in.
Professor, can I share mine then?
Okay.
I just did a simple one. Can you see it?
Yes.
I just did this simple.
Okay, he did 2 + 2 minus 3 + 3. There is a problem here, not 2 + 2, 4, minus 3 + 3, 0. Here, there is no problem, but this thing, 3 minus 3 makes 0, then the result is 4. Then we're using there in a code cell the Python, interactive Python, because this is interactive Python as a calculator. Then the following instruction, let me go. Can we have anybody else? That was Julian's notebook. Then I'm going to share my screen and continue.
Okay, I will stop sharing.
Wacht happened here? Share screen, share. Okay, are you guys seeing my screen?
Yes, we're seeing the screen.
Okay. Then that was the first instruction. They say you can use Python in this way. This is interactive Python, and send any command here and order the execution, and you will get the result. This first one is something that we call a variable. Then you can put a name. Here is the name X. You can use capital letters or small letters. You can use, the first one has to be a letter and the rest can be a combination of numbers of letters. And define a name and assign a value to the name. From that on, when you use X, it will have this value. Then in this one, what is being done is like, you are telling Python, define a variable, define a name that is going to be a label, and associate the value to the label. Later on, we're going to see one example. What they're saying here is, if it's something that it produces a result, Python writes the result of the particular operation in the cell. If you have something in a cell that produces a result, then you get the result immediately after you order the execution. But here, over here, we say execute this, and it's like, the result is null, then it doesn't print anything. But he created a variable called X, and he put the value 2 in X. I'm gonna just do one example here just to illustrate what happened. If I say, now do X plus X, what do you guys think it will be the value of if I execute this instruction? I assign to X the value of 2, and now I'm saying calculate the addition of the value or whatever value has in X plus the value that you have in X. What will be the result of this one?
4.
4.
4.
Then that's what we call a variable. Then here it was not in the thing, but we define a variable. Here it was just to illustrate. If you define a variable, you don't get this. If I want to delete a cell, I say, I don't want this little instruction here anymore, then I delete that cell with these scissors. I can add cells after the cell that I'm in with the plus, and I can delete a cell, either text or, let me just copy this one to keep it. I can delete a cell as either text or code with the scissors. Then if I want to record that one, I add this one, I add this text, and I say this is Markdown. Because if I don't say it's Markdown, then he thinks it's an instruction that he can execute. Then in the following cell, what is illustrating this lesson is, if you have multiple instructions, Python only will give you the result of the last one. Then here is like, you have 2 plus 2, that's 4. And then you have 3 plus 3. Python is gonna execute all the instructions, but it's gonna print out only the last result if the last instruction has a result. If it doesn't have a result, it prints like this. Then if we execute these 2 instructions, it's like, okay, 2 plus 2, 3 plus 3, the 2 plus 2 is not printed, it only prints the result of the last one. If you want things to be printed, you can use this thing. Actually, here we're using Python 3.5. Okay. Here you guys will see that we're using Python 3.5. In Python 3, some of the prints require brackets, but let's gonna check this instruction. Then this instruction is gonna do this calculation, and we're saying print. Then it will write that result, and it will write also the result of the last instruction that we have in that cell. Then it's like, okay, 2 plus 2, and write that result, and then 3 plus 3, and because it's the last instruction in the cell and the execution produces a result, then you have the 6. Then you guys do some other examples of this, like write 3 instructions here and confirm that you guys get only the last result. Let's add something like this, 7 plus 7 by 5. Then if you check, it executes everything, but it only prints the last result. And in this one also add anything that you guys want, print 7 by 5 here, just to see if I have prints. I will have the result, I will have this result, and I will have this one too, in that order. First this one, next this one, and then the output. Actually, the output of the cell has the value of the last instruction executed that produces a result. Then you guys do changes in these cells here, executing a command. That's explaining how you execute an instruction or command in the interactive Python environment. You just create a cell that is code, you leave it as code, and then you write any executable instruction here, and then you will get, if you execute that instruction, you will get in the output the result of the last instruction that you have. If you have multiple ones, you only have one instruction there.
Yeah, thank you. That's you.
So do some changes, and then Julian, can they show us back that they are like following us in this part? Because after this, the idea today was to try to cover this complete lesson, the introduction to the interactive Python environment.
They can share their screens. They have the ability to share screen.
Okay, like everybody, I'm gonna see at least at this point the screens of all. Do any changes of the things that we explored before, and share with me. I don't know what happened with my Zoom.
But we still hear you, Professor.
Yes, okay.
I have a question.
Yes.
According to what you said, okay, I cannot hear myself anymore.
Je moet even op mute gaan.
Okay. Chair, I'm gonna mute my mic, then you can talk and you don't hear yourself back.
Okay. My question was about the homework that you just gave us. Is it only lecture 1 that we have to make, or 1 to 5? Hello?
Professor, are you there? Er is iets met zijn internet waarschijnlijk aan de hand.
Hij zei dat hij zichzelf zou muten. Hij zou zichzelf muten. O jee. Maar als ik het goed begrepen heb, Julian, moeten we lecture 1 alleen maken? Of moeten we een, hoe heet het ook alweer? Lecture 1 tot en met 5 doen?
Ik snap die niet echt. Ik snap het niet. Ik snap niet wat de vraag is. Okay. Dus dat ding van Python, dus waar we bezig mee zijn.
Zuiver, dat is bij die introduction research, toch? Waar je moet gaan klonen.
Hebben we gewoon lecture 1 genomen en dat hebben we gekloond om even erin te werken.
Prima.
Dat hebben we gewoon gedaan.
Ja, dus maar dat is mijn vraag, want hij geeft aan dat we moeten het andere gedeelte afronden, toch? Of heb ik het verkeerd? De resterende. Hij wil zien wat als we het zelf kunnen doen, toch?
Ja, maar dat is nog steeds een lecture 1. Is nog steeds een lecture 1. Ja, is nog steeds een lecture 1. Je moet gewoon een van die codes aanpassen. Een van ze. 7, 8, het maakt niet uit of je maakt een nieuwe zoals hij aan heeft gegeven. En dan proberen. Hij wil wel dat je eentje maakt met multilijnen nu. Dus dat je dan die print gebruikt, zodat alles dan te zien is.
Ja, dus dat allemaal heb ik begrepen, maar ik vraag, want hij zei, we gaan werken in 1 tot en met 5, maar nu moeten we gewoon in 1 door blijven werken, toch?
Ja, we werken gewoon in 1 door.
Oké, prima. Dat was het. En we moeten alles afmaken in 1, no? Want ik zie een aantal dingetjes.
Je moet 1 gewoon laten zien. Hij wil gewoon 1 zien.
Oh,
dat je 1 hebt gedaan. Zodat hij dan ziet dat jullie bezig zijn. Dat wil hij gewoon.
Oké, prima.
Professor, are you still there?
Here.
They can show you what they did.
Yeah, I can show my screen. And I was here in Quantopian. What happened with my Quantopian Suriname? I'm here, no? Then, was everybody able to do little changes in these commands and see how the text and the command, executing a command inside interactive Python work?
Yeah.
Okay. Then the next one has a little bit of programming, but it's just to illustrate what do you see when you have the execution of something that takes longer time. Then in Python, you can do repetitive things that repeat a number of times. Then in this one, we're gonna see a cell that is gonna assign to a variable an initial value of 0. And this instruction that is called for is telling repeat whatever is here for this index I in the range of here is 10 million. Then I is gonna take the value 0, 1, 2, 3, 4, 5 up to 9,900,099. Like up to, it's gonna, I'm gonna do a little thing just to illustrate this. I'm gonna change this one just a minute with a value that is less. If I do this thing, it doesn't have it's gonna print the value of C, because here this last C is just show me the value as output, the value of C, but C is not gonna change here. I'm just gonna print I. Then this is gonna say repeat this for the values of I that are between 0 and 10. Actually, it's everything that is from 0 to every value that is less than 10. Then if I execute this one, what I'm gonna have is prints 0, then prints 1, 2, 3, 4, 5, 6, 9, and until 10. Then this is a structure that we're gonna see later that is called repetition. You can tell Python, please repeat this for all these values of I that are in the range 0 and this value. Then it's saying repeat this instruction. And you have to do this thing that is called indentation. Everything that is gonna be repeated, if you leave it like this, Python is gonna give you a mistake. It's gonna say, ah, no, you're saying here, repeat something and there is nothing, because for him, this instruction is out of the scope of this repetition. It's like, for him, it's like you're saying repeat something, but there is nothing here. Then anything that you wanna do here, like let's say C plus, C equal plus the value for C plus I, the one that was originally. And I do this, it's gonna repeat these things inside, it's gonna print the value of E, it's gonna add C to the previous C plus the new value of I, and it's gonna print C here. And at the end, it's gonna print these things, 3 things, because these things are indented like this. He's gonna assume these things are inside of the repetition. These are the things that you wanna be repeated. Then it's gonna print the first value of I is 0, and the addition up to that point is 0 plus 0, 0. Then the second value is 1, and the second value of C is 0 plus 1, 1. And then you're gonna see this is the addition of the numbers like up to that point. Like the second number, they are like pairs of numbers. The first one is the I, and the second one is the addition up to that point. Up to that point is the addition 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, 10 plus 5, 15, 15 plus 6, 21, and these are the additions. Then, actually what they are doing here is not illustrating this one, because this is pretty standard, but here we are explaining that. This is a instruction in Python in which you can repeat a number of times certain block of instructions. With this variable that is called control variable, you control the number of executions and use the values if you need it, like here. But the one that we have here, what they want to illustrate, and we want to remove the print because it actually cannot print those many numbers. It's going to say, I want to repeat this 10 million times. Then it's going to do the same thing that we were doing here, but it's going to do it 10 million times. Then what they're going to show you is when you have executing something that is taking longer, while it's executing, it's going to show a star here saying, I am executing this instruction, but it's taking longer. I haven't finished. Then I'm going to execute that one. And then you get this thing. But actually, computers are quite fast. He generated the numbers between 1 and 9,900,099, 9,900,099, because those are the values that he has. Actually, if I print the last I here, if I don't print the C, that is the addition, it will show me the last value of I that we have. That is that value. 9,900,099,999,999. Because it goes from 0 to the value that is before this, and it's executed 10 million times. But because you are executing the value of 0, you are executing this number of times. 0, 1, 2, then is this number of times, and the values of I are 0, 1, and so on. Then this is just to say, when a cell, actually I can execute it like 100 million times, and it's not going to take that longer. While a cell is executing in the computer, it's actually being executed in the computer there in Quantopian, not in the local computer. But sometimes it's in the local computer now with Colab, but it's going to take a little longer. But it says when you see a star in this here in front of a cell, it's because that cell is being executed at this moment and it's taking a little longer. Then that was the last I. It was, now it's 99,999,999. The last value, if I print the addition, I can execute it again, and then this is what computers are good for. Computers are good for executing really fast arithmetical instructions and sometimes things that combine letters and numbers. Then if you try to do this by hand, 1 plus 2 plus 3, okay. But if you say 100 million, no, but a computer can execute probably 1,000 million of instructions in a second. Then doing 100 million additions is going to take some 10th of a second. What is taking here is the communication to the server in Quantopia and coming back with the answer and printing it. And this is the addition. The addition is a very huge number, like, I don't know, some millions of millions, like trillions or something. Then this is the second thing that is here. Knowing when a cell is running is because you get a star here while it's running. Then Python is using, as we say, it's an ecosystem. Then in Python, we're gonna see in the next class, in the introduction to Python, everything about Python, how to do repetitions, how to do arithmetical operations and stuff like that. Probably we have to stop very soon, but Python uses libraries. Then one of the things that we have here in the ecosystem is this thing called NumPy. Then I was telling you, what is NumPy? Then interactive Python is this thing that we just saw. These research books are this interactive Python. Is a sort of notebook interface where you have cells and you can execute little pieces of code and little pieces of little pieces of text. Then you guys have here Python. If you guys want to check the IPython organization, it's called this. Then you can download a local thing to do interactive Python, but it's easier to, for us, it's gonna be easier to use in Quantopian, but you can have it in your local computer, a little system that allows you to do those cells, and you can download the local introduction there. And actually, there is this other environment called Collab. This is gonna be the last thing that we will present today. If you are inside a Google account, a Gmail account, Google provides an interactive Python online environment. Then that is, you can open it with this direction, collabresearchgoogle.com. I'm gonna check here just to see a video and we'll finish with this. If you search for Collab, it mentions Google Collab. And I'm gonna go here and we're gonna see this video with the guys from Google explain what is Google Collab. It's a 3-minute video.
Hi, and welcome to this video series on Google Colab. I'm Jake Vanderplas, and I'll be your guide today as we look at what Colab is all about. Google Colab is an executable document that lets you write, run, and share code within Google Drive. If you're familiar with the popular Jupyter project, you can think of Colab as a Jupyter notebook stored in Google Drive. A notebook document is composed of cells, each of which can contain code, text, images, and more. Colab connects your notebook to a cloud-based runtime, meaning you can execute Python code without any required setup on your own machine. Additional code cells are executed using that same runtime, resulting in a rich interactive coding experience in which you can use any of the functionality that Python offers. For example, here we define a variable containing a range of 10 numbers. In the next cell, we loop through this range, printing the square of each number. For convenience, we use the Shift-Enter shortcut rather than the play button to execute the cell. Cell outputs are not limited to simple text, however. They can contain any number of dynamic, rich outputs. For example, we can search Colab's built-in library of code snippets and insert code to create an interactive data visualization. This particular visualization is created with Altair, one of several third-party visualization libraries that Colab supports. Colab notebooks can be shared like a Google Doc, and for this purpose, it's useful to use text cells to provide a narrative around the code you've executed. Text cells are formatted using Markdown, a plain text document format that's rendered on the page. Markdown format is simple and powerful, allowing you to add headings, paragraphs, lists, and even mathematical formulae. If you would like to share your notebooks with others, you can do so via Google Drive sharing, or even by exporting your notebook to GitHub. The notebook is stored in the standard Jupyter Notebook format, and so the notebooks you create can be viewed and executed in Jupyter Notebook, Jupyter Lab, and other compatible frameworks. The convenience of sharing notebooks means that you can find and explore many interesting notebooks around the web. One useful collection is the SeedBank project at research.google.com/seedbank. For example, the neural style transfer seed shows how to use deep learning to transfer styles between images and includes a link to a Colab notebook where you can run and modify the code. To learn more about Colab, visit colab.research.google.com and find the Welcome Notebook, where you will find links to tutorials and other info about Jupyter and Colab notebooks. You can also find the remaining videos in this series, which will explore Colab in more depth. In the next video, my colleague Lawrence will explore how to install TensorFlow using Colab and how to use different runtimes to access things like the GPU. See you there. Hi, I'm Jake. I'm a
Okay, then, even though we're gonna be using the notebooks inside Quantopian because we wanna use the data specialized from Quantopian, anything that is Python can be used in the Colab notebooks that are like writing docs in Google. But actually what you write there is like pieces of text combined with pieces of Python programming. And as you saw in here, when you go here, you get like getting started, and then you have also lessons of how to use Google Colab. Sorry, getting started. Then in getting started, like let's say they have a simple calculation, seconds in a day, that is this one, and I execute that one, and I get 60 seconds in 60 minutes and 24 hours in a day, then I get this number of seconds. Then you can do things, but also next time we're gonna see these things later, but just with like importing a library of mathematical things that we're gonna see next time, and another library that allows to do plotting, I can just visualize some data with just simple instructions. It's like nothing so fancy, like everything to plot this simple visualization to calculate 200 plus a random number that goes on top of the 200 and calculate 100 of those values and then plot these things with certain properties. I can visualize this value. If this was the value of like, I don't know, a number of like COVID cases, I just plotted. We're gonna learn how to read data from the outside and do processing of that data and then plot the data. But it's gonna be after like this. You guys see here in the getting started in Colab that they jump from the simple just instruction that we did, just assign a variable with a particular computation. They go into this, but then we have to tell you what is the NumPy library. That is the next library that we have after these interactive books that are IPython and Jupyter. We have the NumPy, and we're going to tell you when they create NumPy and added this NumPy as an extension, a library to use certain types of data, and why is it used. And then the pandas one that is used to collect data that is in like Excel kind of format, and also reads comma separated values and Excel values. And later on, we will see how to plot data. And with those tools, you guys have to build in groups of up to 4 students, then 2 groups, or minimum 2. Then we can have 4 groups or 3 groups or 2 groups. Build the best visualization that you guys can build, combining information of COVID and economic variables, and post it in the contest and see what happened in that contest. It's gonna be a little bit demanding, but it's not too challenging. These Python visualization tools are quite simple, as you guys saw. And then we have 2 environments to explore. We were gonna be working in the Quantopian environment to be able to use the data, private data they have available for free inside the platform with sub functions. But also we will be looking for a standard Python visualizations that use particular data that we can kind of adapt and modify and include in our graphic analysis to try to find things there. So questions up to today, then Leonardo will continue with the introduction to research next time, like following examples with you guys. And then we will try to cover these 5 lessons slowly inside Quantopian. Sometimes we will include things from outside that use only standard Python with no libraries from Quantopian to see visualizations. And then at the end, we will be working with you to try to improve your data visualization as such. Just for grading is gonna be 3 things. At some point, we're gonna ask you to do a Colab infographic or modify one infographic that you guys find. If it's COVID related, better. Do it inside Quantopian and try to use in that one, it could be the other one, but plus inside information. There is also some places where you can find financial information for free. At some point, we're gonna check, like in Yahoo Finance, you can get prices of stocks for free, but then you have to download one by one. In Quantopian, you can download 8,000 prices and have it like in a sort of like array, easy to access. In the other one, you have to download company by company, and it's difficult. Then probably the collab infographic is gonna be with standard information, easy to access. And the Quantopian infographic is gonna be the basic one. And the final one without feedback and collaboration with Leonardo is gonna be the one that you guys submit to the contest, to the challenge in Quantopian. So, questions so far? No questions? Okay.
Not
I-
yet.
Ik denk dat de vragen
Oké.
zullen volgen wanneer we bezig zijn met die opdrachten. En daarom heb je echt vragen. Want meestal als je begint aan een uitvoeren van de opdrachten, dan merk je dat iets misschien onduidelijk is of zo. Maar voor nu, geen vragen vanuit mij hoor.
No questions, Professor.
Okay. Then next class, Leonardo, that was hearing here on the background at some point, he will continue with the introduction to research, and then we'll continue slowly, but we have to get feedback from you guys. You have to go and do the little exercises to be able to learn how to do little things before it gets complicated. So you guys are able to work together, developing a good infographic for the challenge. Okay?
Yes.
So also Julian is available during the week to try to help you up to now if you to catch up, and in the other lessons he will be working with us to try to have you like doing a infographic that is like has a chance of compete in that challenge. Okay, see you guys next week.
Okay.
Okay. Yes. Bye-bye.
Okay,
Bye-bye.
Professor.
Bye. Have a nice
Good
evening.
night as well.
Good night.
Bye-bye. How you doing?
Julian, if I end the meeting, I stop the recording, or I have to stop the recording, and you stop the recording and end the meeting?
I think you just have to stop it, and then I will have to go out also, and then it will automatically start downloading
Okay.
the recording, I think.
Okay, then I stop the recording. Do you want to stop the cloud recording?